In this video, we are going to go over dissolving covalent and ionic compounds in a solvent and solvation of covalent compounds. So forming solutions. When a solution is formed, the solute particles become surrounded by solvent particles in a process called solvation. When the solvent is water, solutes undergo what's called hydration. The solubility of a solute in a solvent depends on the polarity of the solute and the polarity of the solvent. So you can see here that we have a sodium ion and it is solvated with water molecules all around it. Solvation of compounds. Solutes dissolve in solvents with similar properties. So if you have a polar solute and a polar solvent, it's going to be soluble. Polar solute and nonpolar solvent, it's insoluble. Nonpolar solute combined with a polar solvent, it's insoluble. A nonpolar solute combined with a nonpolar solvent, it's soluble. So looking at this table, you can see that likes dissolve likes. If you have polar and polar, it's soluble. If you have nonpolar and nonpolar, it's soluble. But if you have polar and nonpolar, it's insoluble. These are common polar and nonpolar solvents. Polar solvents, we have water, methanol, and acetic acid. Nonpolar solvents, we have carbon dioxide, hexane, and diethyl ether. And you can look at their structures and see why they are polar and nonpolar. So solvation of polar covalent compounds, intermolecular forces of attraction between the solute molecules are broken when you introduce two polar covalent compounds together. So a polar covalent solute compound and a polar covalent solvent compound. The intermolecular forces of attraction between the solute molecules are broken, and new intermolecular forces of attraction between the solute and the solvent are formed. No covalent bonds are broken during solvation. So when a polar solute contains hydrogen bonds is added to a polar solvent containing hydrogen bonds, the hydrogen bonds between the solute molecules are replaced by hydrogen bonds between solute and solvent molecules. So when methanol is added to water, the hydrogen bonds between the methanol molecules, these hydrogen bonds here, get broken and are replaced with hydrogen bonds between water molecules instead. And this causes solvation. And one methanol and two water molecules are hydrogen bonded together instead of two methanol molecules hydrogen bonded together. And this forms a solution. Solvation of covalent compounds that are nonpolar. Nonpolar solutes molecules interact with each other through dispersion forces. So when nonpolar solutes dissolve in nonpolar solvents, new dispersion forces of attraction are formed between the solute molecules and the solvent molecules. Tetrachloroethylene, a common dry cleaning solvent, forms dispersion forces with the non-polar oils on clothing rather than the polar solvent water, hence the reference dry cleaning. So when you add this dry cleaning solvent to clothes, the dispersion forces between the tetrachloroethylene molecules break, and they now bond or are attracted to the nonpolar oils that are on the clothes, and it will take off those oils. Supersaturated solutions. There's a limit to how much solute will dissolve in a solvent at a particular temperature. A saturated solution contains the maximum amount of solute soluble in a solution at a given temperature. A supersaturated solution contains more than the maximum amount of solute soluble in a solution and exhibits properties of a suspension. So you can see on the right that we have a saturated solution on the left, and then on the right-hand side, we have a supersaturated solution where we have particles of the solution or particles of the solute settled at the bottom because it no longer can go into solution. When sugar dissolves in water, hydrogen bonds between the sugar molecules were replaced with hydrogen bonds between sugar and water molecules. If we continue to add sugar, though, we eventually run out of water molecules to hydrogen bond with the sugar molecules, and the sugar molecules retain their forces of attraction between each other, and they just settle out in the bottom and don't bond to those water molecules to be solvate. Kidney stones are the result of supersaturated solutions of calcium salts, and the calcium salts precipitate out in solution from solution within the kidneys, and you get those kidney stones. Solubility. An unsaturated solution, or solubility, is the maximum grams of solute that will dissolve in 100 grams of solvent at a given temperature, and it varies with temperature. Unsaturated solutions are, you can add more solute to it. Saturated solutions, no more solute will dissolve. In a saturated solution, any additional solute added will sink to the bottom of the container. A supersaturated solution will become unstable and crystals will form. So if you heat it up to a certain temperature and add more solution to it and bring it back down to room temperature, it is unstable because there's too much solute in there and it will start precipitating out of solution. Immiscible liquids, nonpolar and polar liquids are what's called immiscible, mutually insoluble liquids that form separate layers. Oil and vinegar are an example of nonpolar and polar liquids. Oil is nonpolar and vinegar is polar. You can see on the right-hand side that they form two distinct layers. Water molecules cannot interact with hydrophobic nonpolar compounds, and two mutually insoluble liquids form separate, lower potential energy layers due to what's called the hydrophobic effect. The hydrophobic effect is when water and nonpolar liquids don't mix, because that would require that water molecules break their hydrogen bonds to other water molecules to organize around nonpolar molecules with which they cannot form hydrogen bonds, because remember, nonpolar molecules do not have hydrogen bonds, they only have dispersion forces. Doing so would cause higher potential energy, and everything likes to be in lower potential energy. So instead, the liquids form two layers, which is driven by the natural tendency for solutions to attain their lowest potential energy. Nonpolar compounds in water are said to be hydrophobic or water-fearing. Polar compounds are hydrophilic or water-loving. So in summary, likes dissolve likes summarizes the observation that polar solutes dissolve in polar solvents and nonpolar solutes dissolve in nonpolar solvents. During solvation of a polar covalent compound, hydrogen bonds between the polar solutes are broken and new ones are formed between the solute and the solvent molecules. No covalent bonds are broken in this process. During solvation of a nonpolar covalent compound, dispersion forces between nonpolar solutes are broken and new ones are formed between the solute and solvent. No covalent bonds are broken in this process as well. So solvation is a physical change, not a chemical change. The tendency for a polar and nonpolar liquid to separate into two layers is a result of the hydrophobic effect. A saturated solution contains the maximum amount of solute that can dissolve in a solvent at a given temperature. A supersaturated solution contains more than the maximum amount of solute and appears as a precipitate.